Thanks for having us. This is our first time we've presented here, so I appreciate you having us here. We have two case studies. We just want to go over. These were actually done this year, so it was pretty interesting that when we signed up for this conference, we had the first one, which I'll go through, and then Mark's going to pick up the second one. But we only planned on speaking about the one, but then we had another opportunity with our communities. Our company does a lot of local engineering, or engineers of records for many communities, about 60 plus, for a long time, for 50, 60 years, some of these communities we've been working with too. So I've had the chance to get down. I've had a lot of international experience, local experience, whatever, but to get down to these smaller cities and communities to use GIS and make them understand the benefits it's been amazing to me. It's been fun because they're not the ones that are always involved in these conversations. So the first case study is this village of Woodsfield. It's actually a small community it's about 30 miles off the southwest corner of Pennsylvania. Rural community. It's in Appalachia, but it is one of the communities that we work with from an engineering scale level. They don't have many people, 2,500 people approximately. It's only about 2 square miles. What's interesting is that they actually own and operate their electrical, their sewer, and their water utilities themselves. So it's kind of unusual for such a small community. Usually they're part of the county, but they actually operate their own. They have a mix of 120 and 240 volt. And I'll go into that a little bit further, but they started to do a changeover at some point, but never completed it. But like I think Dr. Johnson said, there were several significant events in their life cycle that occurred that they needed something else besides the paper plots that they've been using for years. So I'll explain a little bit more. Like many communities, they actually started with paper maps, paper plots, as-built, etc. Unfortunately, at some point, and I'm not going to go into the story, but they actually lost it all. Every bit of information on their as-built poles and information on the line network was gone. So the village had also started to move to the 120. It was more of I think it was politics than anything else. They started to move from 120 to 240, but they never completed it because of financial reasons. And then lightning striking twice. This is actually a picture my son took this from he was waiting outside for work and he was watching a lightning storm. But they actually got struck twice on their substation. The first substation was actually a wood structure, so it burned down completely. Everything got destroyed. The second time it got hit, it absorbed a little bit better, but it still completely destroyed a lot of their network. So the solution, they're actually very familiar with GIS from the standpoint, their actual manager, their city manager I got to meet. He travels around, he attends conferences. So he had heard about GIS and stuff like that, but they recognized that they needed to start rebuilding it, but they also wanted to create a digital solution and a centralized platform. They obviously have a lot of staff that go out, and since they're responsible for the network, they have to repair it, they have to update it, whatever. So they actually they wanted something in their hands that they could use instead of, well, they didn't have anything at this point, instead of the paper plots they used to use, but but again, they had no data to put in GIS. So what's next? They didn't have the budget to completely do a field survey at survey grade level, collect. So they actually needed to figure out a more efficient way to do it. What were they going to do? So we actually met with them, kind of talked through options and discussions. They had to locate all their poles, physically locate the XYZ location. They wanted a lot more attribution than what they had off the paper plots, the as-builts, what the conditions were at the time, etc. They were having a lot of issues. These were old poles. I mean, these poles were dating back to the network was really originally set up in some cases. So they were having a lot of issues with woodpeckers, termites, all sorts of things that were tearing down the poles. They were falling apart and they were losing local connectivity. And they don't know if something happened, they didn't know where the network broke and where it leads to, the downstream. So they really needed something to happen here. So the first option we talked about was field collection, complete field collection, sending somebody out in the field, walking around the city, collecting all the stuff manually. The second one was combining aerial imagery and field collection, which we've done before, where we actually locate the poles themselves just for an XYZ location and then plug it into the survey equipment for them to go drive to it so they don't have to walk around the city. And then the third one was combined aerial imagery, other data, and I'll explain that here in a minute, and then field verification with the staff, which is, again, where some of this GIS comes in. As far as the workflow, we knew we had to build an Esri framework. ArcGIS was a no-brainer. We've been using it for many of our communities. Mark does a lot of work with our communities within CT. building networks for their water and sewer lines and stuff. The electrical fit right into it. Just makes sense. It solves their need for the digital solution and a centralized database. But the other benefit is Esri's been building these schemas and building these networks for us to make our jobs easier. We're not building this stuff from scratch. If you're not familiar with the schemas in Esri, I highly recommend you look into them. Mark and I have been talking about a lot, especially with the engineers that we work with. If you're not familiar with schemas, that's the definition. I'm not going to read it to you. We've used schemas from our side for aerial imagery, remote sensing, essentially defining the symbol type, the line type, etc. Esri has created this. It makes our jobs a lot easier. We don't have to manually go through, create the pole types, create the attributes for each one. And we don't necessarily know all the information that goes in these attributes. These lists are longer than what we're familiar with. So those that are working in the field gives you more information to tag into. So we also actually use field maps, Esri Arc Pro and ArcGIS Online, et cetera, was a solution for this. And again, I'll walk through the steps here in a little bit, but the client had no Esri software, and we run into this a lot. These smaller communities know about GIS, but they know that their county may have it, but they have no Esri software. So we actually worked with them. It's very easy working with Esri to set this up. We've worked with many communities to do it. Esri is very helpful. Happened very quickly. It was just an easy process to go through. So as far as collecting the poles, I was the one estimating this project. A little scared because they have no idea how many poles they had. It is a small community, but it still can be a big challenge determining that. I just used a grid approach. It's something I've used in the past successfully to identify. I estimated about 1,400 poles, and I gave a little buffer to that as well. But I just took a grid, laid it across aerial imagery. I counted the number of poles, then multiplied it by the square miles, essentially to come up with that 1,400 poles. So we downloaded the latest statewide imagery. Ohio has a great statewide imagery program. I know PA does too. A lot of data is available. It's actually 6-inch for this county. There's not a lot in this county, so they don't go to 3-inch yet, but they do have a good source from 6-inch imagery. There's also a ton of other imagery we looked at. We actually have near map licenses. Esri has sources. There's just a lot of data out there. Search the sources for the best available. Sometimes you think you have the best, but there's more available. So in the end, we had an imagery specialist go through. He's actually a photogrammetrist and locate the poles. We ended up with about 1,500 poles going through imagery. So I wasn't too far off on my guesstimate, but luckily that was the case. As far as collecting the preliminary attribution, Google Street View has an abundance of information. I don't know if anybody's ever used it for that reason, but we actually looked at. I was shocked that this community actually had Google Street View. Some of these rural communities don't have it, or it's not posted on Google, so it's actually beneficial. The poles don't get replaced. They don't actually move that often unless they redo a street or widen a street. Rarely do poles get moved. So occasionally you have one-offs, etc. But in this community, these poles have been around since the 1940s and 50s and 60s. So not a lot had changed. As far as the XYZ locations, we had pulled those. So this allowed our GIS analysts to actually drive to this pole within Google Earth Street View. So you had all the locations already planned out, made it easy for them to drive through. We did discover some new poles. You're looking through the imagery and you find, there's 2 poles side by side. In this case, they had a lot of broken poles that they left the base in, and they had chopped off the top. They left it for support. They left it for other reasons, but we included those in that as well. So as I mentioned at the end, not all communities or streets have this source, this Google Street View. So please make sure you check before you tell them that I said to use it. So just be aware. As far as field verifying, again, we use field maps. We had provided the Esri tech, or the field technician actually with a Wi-Fi and cellular-based tablet. We find that having the cellular is just kind of redundancy backup, also transfers the data faster. But so he used the tablet. He collected in Esri field maps. We gave him the extracted pole data and the basic attributes that we had, all loaded on the tablet right in front of him. He drove to these poles. He could actually check, view them. He could take a nice picture of the pole. We actually had 3 pictures. Those pictures to the right there are the pictures we took. We were taking oblique shots. These poles happen to have 2 numbers on them. Looked like the original stampings were on there as well. So we took that plus the metal tags if they're available. Again, that was one of those inconsistent things. So sometimes we had to assign a number. Sometimes they had a number. He completed over 150 polls a day. I mean, it was a tremendous speed that we weren't expecting. But utilizing this approach of the combined GIS, the field maps, et cetera, he was able to drive to those 150 polls in a day. The GIS lead was able to monitor, who was Mark. He was able to watch him and how quickly he did this. He picked up speed. I mean, the first few days it was 70, 80, 90. And over the few days he picked it up. It went up to 150 at some point. So Mark was able to show the client. He was able to show us. He was able to show the PM in the market that things were moving fast and moving quickly, and we knew they were occurring. So as far as the field data checks in the office, we did a final QA/QC, final attribution to verify the information was correct. Again, we used all sources that were available to do this, the aerial imagery, the Google Street View, et cetera. We reviewed it with the final. The advantage of the GIS was being able to review it with the Woodsfield staff. They are a rural community. They don't have a lot of network as far as computer networks and stuff like that. They have laptops and stuff that they operate off. Very easy to use AGOL, and so they were able to look at it with us on the cloud. And it was able to, the city manager was able to review it. Again, we were able to review it. The project manager for us was remote, so he was able to see it at the same time. We also offered additional training for Woodsfield staff for the use and maintenance of the electric distribution, because they were going to use it in the field. They were going to maintain it as they moved ahead, whether it was on a phone or a tablet, et cetera. They're going to be able to use this for their project. So this is the end of the first one. Mark, this is the next one.
Morning. Thank you for having us here. As Joe said, we're CT Consultants. We do photogrammetry, we do orthoimagery, GIS. Seems like the last couple of years, I've been doing a lot more GIS projects. And they're as small as that little community that we just did, and citywide information. This community, case 2 here, is Lakewood, Ohio. What they were looking at, large community just outside of Cleveland, mostly residential, but there are several streets where there's a lot going on. If you're familiar with the Cleveland area, Detroit Avenue comes out of Cleveland and it hits Lakewood, and it just explodes with all kinds of things. So the electrical grid there, they were looking at reducing the number of wires and possibly going to put everything underground. So it's a big thing to take on for a community looking to reduce the number of wires, put everything underground. Where do we start? What do we do? We've been working with this city for a number of years. We're helped them with many things in the civil engineering side. They came to us and said, where do we start? So our engineers said, okay, you need this. Well, what is it that you want to do? What is it you're looking to get? They wanted to know what it would take, and right down to even the cost per street segment of what it's going to take to either convert some of the street lights to a solar light or bury the lines underground. So our engineers analyzed all this and said, well, we need a place to start. We need to know the streets. We need to know how many poles, what's on the poles. They brought us into it and said, what's the best way to do this? The other part of this is analyzing all of these streets to know what level of difficulty it's going to be. Some of these city blocks of just house after house, they only had a single street light, every so often down the street. Okay, that's an easy one. Then we came up with this 4-tiered scope so that we didn't have too many things to look at. We narrowed it down to 4 categories. And the thing with the GIS, develop a scope. Here's our scope to work with. So whoever sat down to work on this project had very clear instructions on what level of detail is the breakdown between each of these street levels. So, as I said, the other part of this is they wanted to know what it would cost. If a street segment had a lot of things on it and we had to have a contractor come in with a ditch witch. They wanted to know, what's it going to cost per linear mile to do a ditch witch to bury all these poles. They were looking for a solution. I see smiles on your faces. A lot of people recognize this photo. So GIS sometimes isn't what the client's thinking of. You know, he wants, what's it going to cost for this street? What's it going to cost for that street? How do I do this? What do I do to get the information? We look at it and say, let's put it into GIS. We put it into GIS, then they know all the street segments. They know how many linear miles of streets. They know how many poles are on each street segment. We classify all the poles. We put attributes on them. All the data's in there. Once we did that, jumping ahead, sorry. Again, looking at how to do this. And we just finished Woodsfield earlier in the year, and we're like, it worked great for that. Let's do the same thing here. One of the things they were looking at is all of these wires. They also wanted to know, what's the sag of the wire? How low is that wire? So we looked at mobile mapping option. Drive it with mobile LiDAR. Now you've got everything, including, you can see all the wires. You know the height of the wire, where it crosses the street, all the the network of wires is all available. From mobile LiDAR, we could run it through TopoDot, set the intensity level for that wire, boom, all the wires pop. And then you just go through and tag all those, and now you have a line work of all the wires. Well, communication back and forth between our engineers and the engineers to the client, and the client said, it's going to cost how much to drive our whole city? Ooh. What's plan B or C? Again, we went back to the aerial photography, ortho photos. We map all the poles that way. From the aerial, when we were plotting the pole, we could also see, okay, it has a light. It has a crossbar. It has how many transformers. So when we went through this, as we're plotting it, ArcGIS Pro, we're telling it, fill out all the attributes as you go. Now we've got it all plugged in. So, can't see the screen, glasses. So as we're looking at this, we identify a workflow. Again, very important to any project, GIS included. If you don't have a workflow, then your project becomes an amoeba and you get off track. We set a workflow on our projects, and everybody that sits in on it can follow along, and we're able to track everything. Again, ArcGIS, as Joe said in the other slide, was a no-brainer here as well. This project, normally in ArcGIS Pro, AGOL, we would look at using the new utility networks. This client didn't really care about GIS at the start. The community does have GIS. They use GIS in several of their service areas. But we've looked at this and said we can use the geometric network, the older one, plug it through. We've got all the basics there of attributes, and we can just put our data in there. So picture over there is orthophoto with all of the poles for the whole city on it. As I mentioned, each of the poles had different attributes on them. So therefore, we were able to symbolize those poles through the symbology part of it. This made it very clear as you were looking at it what was on that street. It also helped us with going through, and you can see here the far left pole is just a simple street light. And the next one over has a little bit more on it, and the one in the bottom right has a lot on it. So as we were going through and attributing the poles, each street segment, we classified it as we went. So we said, okay, this street just has street lights on it. Simple, easy to go through, and that street could easily be converted to solar power lights, low voltage, clip the wire, done. Most of these community areas, the city block areas, the electric supply was actually in the backyards. So for all of the housing areas, probably 80% of them had power poles in the backyards. They didn't really care. They didn't want to know what was in the backyards. They only wanted to know what was along the street. So it made it easy for us to determine what streets were what level. So given that we did all the coding ahead of time, all the attributes on the poles, tagged all the streets as far as easy, difficult, extreme, when our engineers looked at this in AGOL, they could very quickly go down through a street and see the different symbology of the poles and say, yes, we agree. This is an easy street. This is a difficult street. There were a few streets that we put in as difficult, and they reviewed them and said, let's make these streets extreme. So everything that we did was looked over by our project engineers to make sure that we were all on the same page. Very clear and understanding. So then our engineers said, okay, they took the data, and some of our engineers are like, what's a shapefile? What do I do with this? I need an Excel file. Perfect. Take the DBF file, I load it into Excel, save it. Easy to do. Part of what we did here, as I said, we tagged the streets, and we also tagged all the poles on that street. So through ArcGIS, I could find the street segment, find the road ID, search for poles within 50 feet of that center line, and automatically apply that road ID to all those poles. Use the data. The data is there. Use the tools in ArcPro. Boom, you got it. So with this, the engineer then got the Excel files. They could run through all of this, show the client what it would take to do this.